looking at this first. So look at a small diagram. Can you all see the fire? Can you all see a fire, reddish, yellow color? Okay. So you're all able to see fire, right? Kaveri, are you able to see the fire? Okay. Kaveri works for Pollution Control Board, I believe, and one of my proud students. Anybody, can you all see the fire? You can see the fire. Okay, good enough that you're seeing the fire. But can you see the heat? Or can you tell me at what distance the heat is there? Or where does the heat stop? Or where does the fire start? It's really tough because the fire is also constantly moving, changing its position, maybe at the top of the. And the heat also is, of course, sometimes high, low, sometimes high, low. Exactly, you're able to see the fire, but not the heat. Exactly in the same way, I want you to understand that when you have a human or a physical entity, there is a chance of an surrounded aura, some sort of an energy around that human being. Probably this aura is lost as soon as the human life is ends. So whether it is heat and fire, whether it is humans and aura, or whether it is a voltage and electric field, they're all the same. You all understand that an antenna is given with an voltage, a waveguide is given with an voltage, and you can't see the voltage inside it. Neither you can see the electric field outside it. Both are physical. Both physically exist. Actually, most of us are taught that electric field is imaginary, electric field is imaginary lines. It's not correct actually. Electric field is physical, but you cannot see it. Voltage is also physical, but maybe you cannot see it. So the logic is when you have a cause called as voltage, its effect is electric field. Just as cause is fire, effect is heat. Exactly the same way. Voltage is the cause, electric field is the effect. This is what the definition of electric field is. It's a form of energy around a charge and influences other charges. So when I come close to this charge, or when I get into its vicinity or the region or field, it's going to have influence. It's exactly electric field. So electric field is a form of energy that's around a charge and influences other such charges. That could be a better definition, but I'll give it much simple like this. It's a force in and around an voltage. Whenever I have an voltage, there is an invisible force around it. That force is what is electric field is. So it's something that's spread in three-dimensionally around the voltage. The voltage could be to a satellite, or it could be a waveguide, or it could be to a cell phone tower. But whenever you have an voltage and there is an electric field surrounding it, please remember that you have to understand it in 3D. That means it needs a lot of maths. So once I mean 3D, I mean maths of identifying electric field positions, wire positions, current wire positions. So it needs Pakka 3D. So I hope the definitions are clear. Any doubts up till now? You can feel free to ask me anytime. Feel free. I hope it's very clear. The definition is clear for electric field, especially connecting to the human aura. Because replace this antenna with a human, understand the electric field around it as its aura. Replace this with an fire and heat, you understand everything. You got the point? Okay. Can I move on? This is one of the reasons, students, when I teach electromagnetics, I always tell you that electric field strength has the units of volts per meter. That's how the strength is measured. So if there is some voltage V, what is the field here depends on the distance from the voltage. So if I give kilovolts to the satellite, I get a field of millivolts at the receiving end. So kilovolts given to the satellite converts as millivolts at the receiving earth station. So that's why field strength is expressed as volts per meter. And since charge has got the units of coulombs, you can express it as coulombs per meter square. So remember, electric field strength has got two units because the cause is either charge or voltage. The effect is therefore expressed in terms of cause, voltage, or coulombs. That's something simple enough, basic enough. Now come to a current wire. When I talk of current wire, yes, please. Any question, anybody? Okay. Now the same word voltage are replaced with the word current wire. Imagine a current flowing in a wire which is invisible. Let me tell you that it's not visible. You always have a surrounded energy around that invisible electric field. That's what is magnetic field is. So magnetic field is yet another force in and around a current wire, which is again spread in 3D around the current wire. So magnetic field, don't always think about a bar magnet or earth magnetic field. That's a very rare thing I discuss. Magnetic field is something that comes because of a current wire, and it is all around the current wire. So again, you need to understand 3D maths. So without 3D maths, there is no subject. Magnetic field, therefore, the strength is expressed back in terms of ampere per meter. I'm sorry, I think sharing is off. Okay. Yeah. So see that magnetic field strength is expressed in terms of ampere per meter or Weber per meter square, where we'll discuss what is Weber actually. So electric field is expressed in terms of volts, magnetic field is expressed in terms of amperes, and there are two measures, strength and density, intensity and density. This is how I link to four Maxwell's equations. Why there are four Maxwell's equations? Because there are two measures of strength. So that comes four Maxwell's equations. So agenda is today you should understand Maxwell's equations physically, not mathematical, but physically you should understand what are Maxwell's equations. So the summary of the discussion is, the final summary of what I'm trying to teach in the last 5 minutes is, if you talk of mechanical students who talk about the materialistic visible world, pulleys, gears, they talk about mass, and mass understand that it has got potential energy surrounding it or kinetic energy surrounding it. So any mass that mechanical or civil people talk about the materialistic world, they talk of the potential and kinetic energies of a mass. That's exactly what we people do. In electronics, which is completely invisible, where we have a charge, not the mass, we talk of electric and magnetic energies. The beauty is mechanical people, at least they can see some mass or some physical entity. We electronics people can neither see the charge nor the electric field and magnetic field surrounding it. Therefore, we need pakka maths. We need 100% perfect maths to learn it. That's understanding of electromagnetics. So the summary is, when you have a mass, and if it is static, it's got some potential energy surrounding it. Suppose the same charge, if you replace the word mass with charge, we say electric field. So mass has got potential energy, charge has got electric field. But the same mass, if it is moving, we say it's got kinetic energy. The same charge, if it is moving, we say it has got magnetic field. So static mass, potential energy, static charge, electric field, moving mass, kinetic energy, moving charge, magnetic field. That should put a nice summary to the discussion. Any questions, anybody so far? So I could define what field is. I could tell you what